Good morning friends. Today we are going to see the next point from the topic mechanical properties, that is the viscosity. Friends, this is the last point from this topic because after this the next part will be get cancelled from your syllabus. So today we are going to complete this topic and I think for terminal examination, rotational dynamics and the mechanical properties of fluids, these two topics are there. So your terminal syllabus will be complete today. Now, here regarding the viscosity. So, what is the viscosity? Viscosity is the property of liquid by the virtue of which it opposes the flow of liquid. It means here, in order to explain the viscosity, I have drawn the two diagrams. You can perform the general experiment at home also. Take a plain surface on which you can put the water and you can observe the time taken by the water to reach at the bottom. Again, you can take the same slide and put the honey, or you can put the oil drop and you can observe. Then you will find that the oil will take the larger time to reach at the bottom compared to the water. So, what we can conclude that compared to the water, the oil or honey is more viscous. So, here when the viscous liquid is flowing, at that time the central layer will flow fastest in the viscous fluid. But if the liquid is a non-viscous, then the different layers will move with the same velocity. So based on that observation also, you can identify whether the liquid is a viscous or non-viscous. So what is the viscosity? Viscosity is a property of fluid by the virtue of which the liquid opposes, or the driving force opposes to the speed of liquid. In order to decrease the speed of liquid, viscosity is necessary. Friends, again we are going to study the viscosity with the help of diagram. So here the liquid layer will be get divided into the different parts. So suppose this is a layer at distance x, this is a layer at distance x plus dx, and this is a stationary layer. At the distance x, velocity is v. At the distance x plus dx, velocity is a v plus dv. So the liquid will be get divided into the different layer, and when they are flowing, in the one layer is flowing in the upward direction, at the time the other layer at the bottom will opposes, or that is called as a dragging force. So this dragging force is responsible for the decrease in the speed, and that creates a viscosity. So remember, the viscosity will opposes to the flow of fluid. So after covering certain distance, the fluid will again come to the rest position. Okay, friends. Next part of this topic is the definition of the velocity gradient. So what is the velocity gradient? So the rate of change of velocity with distance measured from the stationary layer is known as the velocity gradient. It has the SI unit dv by dx. In short, you can say the ratio of velocity to the distance is known as the velocity gradient. So dv is the velocity, dx is the distance. So this is regarding the velocity gradient. Friends, we have seen the temperature gradient. So when the word gradient will come, always divide the physical quantity with the distance. The temperature gradient is temperature divided by the distance. Again, velocity gradient, it means velocity divided by distance. You have again current electricity, you have studied about the potential gradient. What is the potential gradient? It is the ratio of the potential difference to the distance. So remember, when the word gradient comes, at that time, at physical quantity, we should divide with the distance. So what is the velocity gradient? dv upon dx. So what is the velocity gradient? It is a ratio of change in velocity with the distance measured from the stationary layer, dv upon dx. That is a velocity gradient. Friends, next point on this topic is the Newton's law of viscosity. This Newton's law of viscosity is very important and we will ask for the 2 or 3 marks. Based on this, some numericals are also created. So what is the Newton's law of viscosity? The Newton's law of viscosity is applicable for only viscous fluid. So it is observed that according to the Newton's law of viscosity, the viscous force acting between the layer is directly proportional to the area of the layer and directly proportional to the velocity gradient. So F directly proportional to A, directly proportional to dV upon dx. Therefore F is equals to eta A dV by dx, where eta is the coefficient of viscosity. If we want to write the formula in terms of the coefficient of viscosity, then eta is equal to F upon A into dV by dx. The SI unit of the coefficient of viscosity is Newton's second per meter square. This information you have read for the 2 marks. Again, I am going to explain this part. The question may be asked, explain the Newton's law of viscosity. So according to the Newton's law of viscosity, the viscous force acting between the layers of the liquid is directly proportional to the area of the layer, directly proportional to the area of the layer, directly proportional to the velocity gradient. So what is the velocity gradient? dV by dx. So F directly proportional to A dV by dx. F is equal to eta A dV by dx, where eta is a constant and this constant is known as the coefficient of viscosity. If you want to write the formula in terms of the coefficient of viscosity, then what is the formula? Eta is equal to F upon A multiplied by dV by dx. The SI unit of the coefficient of viscosity is a Newton's second per meter square. So this is about the Newton's law of viscosity. Next point on this topic is the Stokes law. So in order to study the Stokes law, one simple experiment you can perform. You can take one beaker that is filled with the water. You can take the small spherical body or small sphere, or you can take the metallic ball and drop it. You will observe that it will flow through the liquid, and when it is flowing, initially it has some greater speed, but later on it will move with a constant speed through the liquid, and this is observed by the Stokes. So here I have drawn a diagram. Here one sphere is flowing and this is the liquid. So what does the Stokes say? The Stokes says that the viscous force Fv acting, or the viscous force acting on a small sphere falling through the viscous medium is directly proportional to the radius and directly proportional to the velocity to the fluid and directly proportional to the coefficient of viscosity. So Stokes says that the viscous force is directly proportional to the three physical quantities. What are they? Coefficient of viscosity, radius of the sphere, and the velocity of the sphere through the liquid. So F directly proportional to eta, directly proportional to the radius, directly proportional to velocity. So F is equal to, we take a constant 6 pi. F is equal to 6 pi eta RV. So this is the formula for the viscous force according to the Stokes. Friends, in your syllabus, direct formula is given, the mathematical proof is not given, so you should remember as it is. So the question may be asked for the 2 marks. Explain the Stokes law or write the statement of the Stokes law. So what does the Stokes law say? And the viscous force acting on a small sphere falling through the viscous medium is directly proportional to the radius of the sphere, directly proportional to the velocity through the fluid, and directly proportional to the coefficient of viscosity eta. So F is equal to, or F directly proportional to eta RV. F is equal to 6 pi eta RV. Friends, you can remember this law by the formula also. So you can write the formula F is equal to 6 pi eta RV. 6 pi is a constant. Then you can create the law in your own words. And the viscous force is directly proportional to the coefficient of viscosity, directly proportional to the radius, and radius of the sphere directly proportional to the velocity of the sphere through the fluid. In that way also you can write the Stokes law. Remember, this is the Stokes law of viscosity. So we have studied the Newton's law of viscosity, and then we have studied the Stokes law of viscosity. Friends, next point from this topic is the equation for terminal velocity. This question is asked for the 3 marks, and here you have to derive the equation for terminal velocity. So before going to the equation, we should first define what is the terminal velocity. Just we have seen that in the Stokes law, when the sphere is dropped, then after certain interval it will move with constant velocity. So that constant velocity is known as terminal velocity. What is the terminal velocity? The constant velocity attained by a particle flowing through the fluid is known as a terminal velocity. So what is the terminal velocity? The constant velocity attained by the particle flowing through the fluid is known as a terminal velocity. Friends, in your syllabus there is an equation regarding the terminal velocity, and that equation we are going to derive. In order to derive that equation, I have one diagram. Here you can observe this is one sphere which is flowing. Friends, you have to make the sentences as per your diagram. I am going to write only mathematical part. You have to create the sentences. So you should create the sentences as per your diagram. So here we can observe that let us consider one container which is filled up with the liquid and one sphere is dropped here. When the sphere is moving through the fluid, at that time the forces acting on the sphere are upthrust Fu, that is acting in the upward direction, viscous force Fv, that is acting in the upward direction, and the downward force Fg. So these are the forces acting on the sphere, and we have shown this in the diagram. Here two mediums are there, liquid as well as a solid. So rho is the density of sphere and sigma is the density of liquid. That also you should mention nearby the diagram. So it will be very easy to understand the meaning. Again I am going to explain with the help of the diagram that when the sphere is moving to the liquid, at that time three forces are acting on it: with upthrust and the viscous force, they are acting in the upward direction, and the downward force Fg is acting. So these are the total three forces. Again, rho is the density of the sphere and sigma is the density of liquid. So downward force will be get balanced with the upward force. So we can begin the equation this way. Downward force is equals to upward force. What is the downward force? That is Fg is equals to what is upward force? Fu, that is upthrust, plus Fv, viscous force. Now here, what is the formula for the force? F is equals to mg. F is equals to mg. Mass, and what is the mass? Mass is equals to density into the volume. So what is the density of the sphere? Density of sphere 4 by 3 pi r cube. So here we can write 4 by 3 pi r cube rho sigma. Remember this is the value of m. Force is equals to mg. What is the density? Density is equals to mass upon volume. And what is the mass? Mass is equals to density into volume. Volume of sphere 4 by 3 pi r cube multiplied by the density rho into g. Now what is the Fu? Fu is a viscous force. So this is viscous force is a force which is acting in the upward direction. So the same force we can write here. Force has the formula mg. Now here we have to take the density is given 4 by 3 pi r cube. What is the density of liquid? Density of liquid is sigma into g. So these are the two similar quantities. Only what is the difference here? Rho and sigma. What is rho? Rho is the density of sphere, and what is the sigma? Sigma is the density of liquid, because we are taking the two different medium. What is the Fe? Fe is the viscous force, and according to the Stokes law, just we have studied what is the formula for the viscous force? 6 pi eta r v. Okay, what is our aim? Our aim is to find the equation for the terminal velocity. I have to find the value of v. So rearrange the term 4 by 3 pi r cube rho sigma minus 4 by 3 pi r cube sigma g is equal to 6 pi eta r v. Now we have to take some common things. 4 by 3 pi r cube rho minus sigma into g is equals to 6 pi eta r v. Okay, now this is a 6. Take 6 on this side, so it will become 4 upon 18. 4 upon 18. Okay. Now pi will be cancelled. Here is a r and here is a r cube. So one r will get cancelled. So r square rho minus sigma into g is equals to, we can write here v. So 6 is the 18 we are taking here. Again eta is there, so you can take the eta at the bottom. Again I am going to explain here. Pi will be cancelled. 6 is the 18, so 4 upon 18. 1 r will be cancelled. So it will become r square rho minus sigma, and this eta will be got divided. And after cancellation you are getting 2 by 9 r square rho minus sigma into g upon eta is equals to v. So what is the equation for terminal velocity? 2 by 9 r square rho minus sigma into g upon eta. So this is the equation for terminal velocity. If we want to write the equation for coefficient of viscosity, if you want to write this format in the format of the eta, then you can write eta is equal to, now eta will become here, you can write 2 upon 9 r square rho minus sigma into g upon v. Right. Just what I have done, I have taken the eta here, v here. So during the examination, if it is asked obtain the equation for the coefficient of viscosity by using the terminal velocity, then you have write this step also. Okay, so friends, here we have derived the equation for the terminal velocity as well as the coefficient of viscosity. Again, I am going to explain this part once again. The question will be asked during the examination: obtain an equation for terminal velocity of liquid. Then first we should write the definition. The constant velocity attained by the particle flowing through the fluid is known as the terminal velocity. Then you should draw the diagram. After drawing the diagram, you should write that the in your diagram it is observed that one sphere is dropped in the liquid. The density of the sphere is the rho and the density of liquid is the sigma. The downward force acting on the sphere will be get balanced by the upward force. The downward force are the Fg, the upward force are the viscous force and the thrust. So here we have write Fg is equal to Fu plus Fe. Friends, what is the force? Force is equal to mg. What is m? M is a mass. And what is a mass? Density is equal to mass upon volume. So mass is equal to density into volume. So what is the formula for the volume of sphere? 4 by 3 pi r cube. So 4 by 3 pi r cube into density, that is equal to mass, into g is equal to 4 by 3 pi r cube sigma g plus 6 pi eta rv. After that we collect terms, and after taking 4 by 3 pi r cube as a common, rho minus sigma into g is equal to 6 pi eta rv. Our aim is to find the terminal velocity. Cancel the like term, take the 6 on this side, so it becomes 4 upon 18. After dividing, we are getting 2 by 9. So what is the formula for the terminal velocity? V is equal to 2 by 9 r square rho minus sigma into g upon eta. After rearranging, we can also write in terms of the eta. The eta is equal to 2 upon 9 r square rho minus sigma into g upon v. So this is the equation for terminal velocity and the coefficient of viscosity. Hence, we have completed this topic. Friends, today we have seen what is the law of viscosity. Then we have seen what is the velocity gradient. Then we have studied about the Newton's law of viscosity, Stokes law, terminal velocity, and the equation for the terminal velocity. Friends, make the notes properly. Today we have completed this topic. Thank you. Have a nice day.